Hello, everyone, and thank you for joining us for another episode of Certified, Certiport's Educator podcast. I'm your host, Hannah Crapeau. Join us as we dive into the world of education, certification, and technology. All right. Hello, everyone, and welcome to another episode of Certified, Certiport's Educator podcast. We are so happy to have you here with us and spending part of your day listening and learning. We're grateful today to be joined by a wonderful guest, one of our new certified ambassadors, Ashley Faulkner. Ashley, thank you so much for being here.
Hi, I am glad to be here.
So before we dive into our topic of the day, I wanted to give you a chance, because this is your first time on the podcast, to introduce yourself and tell us a little bit about your teaching experience.
Yes. Okay. So I think we're all unique in how we got started into teaching, and I am no stranger to that as well. So I entered the classroom in 2008 as a distance learning facilitator, waiting for a business position to open up, since that's my background. It took a little while. And while I was doing that, I had students who, because I'm not their teacher as distance learning. Their teacher is on a computer somewhere, pre-COVID, they were already doing that kind of stuff. And they would have issues and questions about, because I had some that were doing computer programming, and it would take a little while for the teacher to get the email and to respond. And these kids were just struggling. And I didn't have anything else to do, really, unofficially, of course. And so I took their programming textbook and started learning to code just because they needed help. And then when a position opened up for teaching, I finally got into the classroom. And then I wasn't teaching programming at that time, but I was able to take my Microsoft Excel students on a field trip to Google. And when they got back, they were so excited about what they had learned and what they had experienced that day. They were like, hey, all right, so we're already taking Microsoft Excel and Access with you. What can we do now? What can we do after this class? And I'm like, well, that's it. And so I got on the phone that night with my CTE director, and I found out that I could offer some more, not more, but I could offer some programming classes. And so that's when I started teaching computer programming 1 and 2, because my students wanted something to take after taking Microsoft Excel. And then in North Carolina, computer programming 1 and 2 went away, and then we started teaching Python. And that's where I am today, teaching Python.
Well, I love kind of that foray. That just speaks a lot to the person that you are, right? Where you didn't have to necessarily pick up programming, but you did. And you went above and beyond, and here you are. And you even talked about this at our certified conference in 2023. And so I wanted to dive a little bit more into that coding classroom. So tell me what it is about coding that you enjoy teaching.
All right, so got to back up a little bit. I didn't just do it for my students. My husband's a programmer, and he would come home every day and he would tell me about his job and what he did that day. And he's speaking English, but the words were going right over my head. I didn't understand a word he was saying. And so kind of helped along with why I wanted to get into programming. I mean, I did do it for my students. Without them taking the class, I can't teach the class. And so why do I enjoy teaching? I enjoy it because I get to understand what my husband's saying now. I also love it because the kids, it opens up so many more job opportunities for them, and allows them to be creative in ways they haven't thought about before. I mean, a lot of them are gamers. And while I don't teach them how to code a game, I'm not opposed to, if that's what you want to do, well, then here you go. Make you an end of course project, and you make me a game. Do what you need to do that, helps to make them more excited about programming. So I enjoy it because it's, even though it's not as hands-on as baking a cake or building a house, those are really hands-on, and you can see it. With programming, you can't quite see it like that, but the kids know what they made, and they have something that they can actually send to or share with the future employers or add to their resume of things that they've actually built themselves.
I love it. That
So
tangible
that's part of,
component I think is so important, right?
yes. I I do love, and when they code it and they get to see it, I really saw this when I taught computer programming before Python. 'Cause we were making apps all the time. We were constantly
Mhm.
making forms and applications that kids, you could check box, change the background, add a picture, make an animation, make it change and rotate and do whatever. The kids got a chance that sense of, I did that, I made that. And I'm like,
Yeah,
yes, you did.
that's incredible. But I know, of course, it's not all smooth sailing, right? We're talking about kind of that tangible, like satisfaction that comes at the end. But of course, there's some bumps along the way. As you've been teaching this for a while, what are the coding topics that you find are most difficult for your students?
Well, depending on the language, they're called functions or procedures. Those seem to be one of the most complicated topics for the kids. And they struggle with those. They seem to be getting looping, and they get if statements. They get that conditional logic, but they struggle with, what is a parameter? How is that different from an argument? And am I like arguing with somebody? Like, no, you're not arguing with somebody. It's just what it's called. Um, so the ways that I help my kids understand those is they understand a variable. A variable is just a container. It just holds a value. That's all a variable does. It just holds a value. And so then when we get into functions, I'm like, okay, babe, we got this. All right. Instead of coding something over and over and over again, you're likely to make a mistake if you keep having to type the same things over and over again. We're going to type it one time and then just call it a couple of times, however many times we need to call it. That's the purpose of a function or a procedure. Now we understand that. Now, sometimes you can call it, if you want, if you need to, with what's known as a parameter. All it is a value that gets passed to it. So if I want to make one that takes a name and puts doctor in front of it, well, I need the name to be able to put doctor in front of it. So I can pass the value of that name as the parameter. And that's what it's called when I'm declaring that function or procedure. It's called a parameter. And then when I actually give it that value, that's what's the argument. And that's where students really get confused, because it's two words for almost the same thing. Like, guys, it's okay. When you declare it, it's a parameter. As long as that word exists inside your function, you're good to go. When you call it, it's called an argument, because that is the actual value that is passed. But it's okay.
So
And I do a whole lot of drawing on the board. And
yes, I was just going to say, so tell me, just in thinking about these topics, obviously the nomenclature and the vocabulary is super important. So how are you simplifying these difficult topics for them so that they understand? You talked about drawing a lot.
yes, I do draw it out on my whiteboard. Sometimes I've had them acted out. I've broken down pieces of code. So I have a complete set of code, couple lines of code. I've cut it up into strips, and then I've given it to them as they walk in the classroom. And with that, have them first put it in order, try to figure out, see if they can make sense of it. And then we step through the code to see, does it make sense the way they organized it themselves. So that's part of breaking it down for them.
I love that idea because I feel like it gets into that visual component of learning. I think that coding, because it's almost like learning a new language, it is like learning a new language. It can feel so
It is.
abstract. And so you can get really muddled into the details. So being able to break it up into visual pieces so that they can see it, I think that that is fantastic. And that's obviously a resource that you've developed on your own. Are you pulling in any other resources to teach Python in your classroom?
Well, first thing that I did was I found loose monitors, and they really were just randomly laying around. And I grabbed enough to fill my classroom so that each computer has two monitors. So my students can research on one while they're coding on the other. Just like programmers kind of do in the real world, they have multiple monitors, one for testing, one for coding, one for research. They may have another or so, but that's pretty much what they do. So I'm simulating that environment for them. So we're coding using Deep Note, but there's lots of other avenues that they could use. They can use Visual Studio. They can use Replit. There's lots of places that they can go to actually code. I use geometrics, and I use LearnKey to help supplement the concepts that I'm teaching the students. And of course, they can always Google the topics to see. I do have a bunch of videos that Microsoft was hosting at one point on the topics to help them understand. But there's lots and lots and lots of things out there to help students understand and kind of grasp the concept.
So in thinking about that, obviously, when I've talked to other educators, one of the hard parts about coding is keeping students engaged kind of through the hard parts, right? There's a lot of kind of background knowledge that needs to be established before they can actually build and do the actual coding that they want to do. So how do you keep your class fun and engaging so that students work through kind of that foundational content before you go into some of the actual coding, the building?
Well, first off, when I'm presenting the concepts to them, I try to be as animated as possible. So like as I'm teaching them if statement or that logical test and everything, I have them. I try to use real world examples. So like you can go out with your friends. You've asked your mom, could you go out with your friends tonight? And she says you can go out with your friends tonight if you cleaned your bedroom and you've washed the dishes. You're like, well, the dishes are done, but that bedroom is not clean. So I guess I can't go out with my friends. You know these things. You just haven't applied them to and to see what that looks like on that end. But you guys, you've seen this stuff before. And so trying to break it down into using real world examples of things that they already know. With like variables, I like to remind them that you can't eat a sandwich that's not been made. I mean, you can try, but if it's not been made, you can't eat it. You can't use a variable that you've not declared. You can't use a function that you've not declared. You have to do these things in a specific order. And so by trying to use real world examples, but to keep them engaged, I try to reward my students by if they finish their work on time or if they finish their work early in class, I've got robots that they can build. I've got Raspberry Pis that they can play with, lots of little tech tools that they get to play with. And that helps to keep them engaged.
I love that there's different ways to keep them engaged, right? There's the reward component, but then there's also just breaking it down enough. I love those real world examples because it really does make it seem so much more simple and approachable. And so it makes the learning portion fun as well as kind of that reward that can come later. But I know that in addition to your traditional CTE classroom, I believe you also teach AP computer science. Is that right?
I do AP computer science, and I love teaching AP computer science. Typically, the way it goes with my students is they've taken Python 1 and 2 before they've taken AP computer science. So by the time they get to that class, even though it's not a prerequisite that they've had any programming background, they do actually typically have more more tools in their toolbox, to help them when they get into that class. So they can take it further. But in that class, they're learning Java, script. So it gets a chance for them to compare the two different languages and see what they can do in each one. So it really does just shake things up a little bit.
So tell me what you do then, because in my mind, when you're preparing students for an AP exam, you might need to approach things a little bit differently than in a traditional CTE classroom, but maybe that's incorrect. How do you feel like you're preparing your students differently in AP Computer Science, or do you feel like it's the same?
Oh, it's definitely different. With the AP Computer Science, because it's a board class, I constantly integrate the AP classroom. I think that's what it's called. Into it, and so I give my students daily questions, and I make unit or weekly quizzes based on the topics to make sure that they're exposed to the questions that College Board thinks that they should know based on what I've taught them. Um, but I also allow my students to have a little bit more freedom in AP because they've established that they know so much. So I mean, I'm giving them quizzes all the time. But with the AP exam, it's actually a two-part exam. They have to actually create a project, or they have to code something that they've made themselves, and then they have to write about it. And I have to give them, before they just changed it. It was 12 hours. Now it's 9 class hours I have to give them to actually do all of that coding. So that's a little different. I don't do those things at all in my other classes.
Oh, interesting. So they're having to explain almost their reasoning and their project, right?
Yes, they do. They have to be able to, what was the purpose? Why did you put that loop there? What would happen if it broke? There's lots of little things that they have to be able to justify and explain that they don't have to do in Python.
Right. And you mentioned that a lot of the students that come into your AP class have taken your Python classes as well. Have you found that the students who have taken that certification are more prepared maybe than students who come in without any programming knowledge? How does that look for the students in the AP?
I can, in looking at my own data, I can assure you that students that have sat for one of the ITS certifications and have passed that definitely do better in my AP classroom because one, they're not afraid of tests. They've established that they know how to take a test, and so they're not afraid to do the legwork that it takes to prepare for that test. Because the ITS exams are no joke. They are, when you pass those, you have earned that pass. And so when the students go to take the AP exam, they know they have to earn that level that they want to be able to pass it.
I love that you have anecdotal data that you've collected that you are able to answer that because you know how your students have done. I think that's phenomenal. And I just wanted to wrap this episode in thinking about everything that you've shared. You've talked about so many different teaching techniques and approaches that you take when you're teaching coding in the classroom. What other advice would you want to share with our computer science or coding educators listening?
Well, the biggest piece of advice I could give anybody, even if you're new, even if you're not new, code the assignments before your students. They're sometimes the instructions are just not very clear. We all understand that some instructions are just vague. We don't quite understand. And if you sit down and put yourself in the role of the student, not only one, do you have a good answer key, you just made it. It also makes grading easier because you know exactly what you're looking for. You just did it. But when the students get stuck, you also have a better understanding of why they're getting stuck and how to resolve that issue. And then I also, before the kids can ask me to help, they have to ask one of the other students. Now, students aren't allowed to help each other in the keyboard or mouse on the other person's, screen. But get someone else, because if they can solve someone else's issue, that learning, it elevates it so much that they're now the teacher, and it boosts their confidence because they were able to solve someone else's issue. So that helps.
You're not the first one actually to mention that. And I think that that is a new approach that teachers are taking in the classroom, that there's an opportunity to collaborate. And I love that because I think when students go into the real world, they're going to see so much more of that than in a traditional classroom setting where it's not succeeding individually, it's about succeeding as a team. So I love the idea of kind of collaborating and teaching each other because that's what a real work environment is like.
Yep. And it's important that we, as much as we can, simulate what they're going to see so that they're better prepared, and it helps their employability.
Absolutely. Absolutely. Well, Ashley, thank you so much for coming on and sharing all of your expertise and experience with programming. Any final thoughts that you wanted to share?
I love programming, and you should too.
I can't think of a better note to end on. So thank you so much, Ashley, for joining us. We really appreciate you.
Thank you.
Thanks for listening to another episode of our podcast. We're so happy to have you as part of our certified community. Make sure to follow and rate our podcast so that we can bring more educators into our wonderful and supportive group. We're also here to connect, so feel free to join us by visiting www.certified.certiport.com.